Hey guys, happy Friday. It's the last Friday before winter break. Woo! All right, so today you have your study island goal for solve systems of equations graphically due. So make sure you get me a picture or a screenshot of your blue ribbon screen. And then also you have corrections due, and they're not optional, so make sure that you get them done. But lucky for you, I'm going to go through all of them right now to help you out. So, question number 1 on your quiz. For this one, it says, which of the following x and y values could be a solution of the following equation? Okay, so it gives you 4 different options, and all you have to do is really substitute that in. So if I start with letter A, I know that this is the x and this is the y. So if I substitute that in, I'm just seeing if it makes a true equation or not. So if y is negative 8, and I have negative or equals negative 1/4 times x, which is 10. So I'm going to put 10 over 1 because I'm dealing with the fraction, and then plus 8. So if I go to multiply this, I'm going to put this negative in my numerator. So that's like negative 10 over 4 plus 8. Is that going to give me negative 8? No, it's not. Okay, so I know that A can be eliminated. And I'm just going to do this with the rest of them. So letter B. Again, my y value is 8, and then equals negative 1/4 times x, which in this case is 4. So I'm going to put 4 over 1, because I'm dealing with that fraction, plus 8. Okay, so multiply, that gives me negative 4 over 4, or negative 1. Negative 1 plus 8, is that going to give me, oh, that's a negative 8. Or no, that's a positive 8. Is that going to give me a positive 8? No. So B will also not work. Let's move on to C. Again, the y value here is 9. So just substituting it in. Negative 1/4 times x, which in this case is negative 4. I'm going to put that over 1 to deal with the fraction. And that gives me a positive 4 over 4, or just 1. And 1 plus 8, does that give me 9? Yeah, it does. So this one works out. So I know that it's letter C. Okay, I need to see this work on your corrections, all right? All right, moving on. Next one says, identify the true statement or statements that describe the graph of a system of equations with infinitely many solutions. Okay, so if I'm thinking about like a graph, there's my x and y axis. If I have a line, or 2 lines, because a system is 2 of them, and it's infinitely many, that means they touch at every single point, right? So it would be like a line, but then the exact same line, right, over top of it. So it's like having 2 of them right on top, because that means that they're intersecting at every single point on that line. So would the equations have the same slope? Well, yeah, it's the exact same line, so they're going to have the exact same slope. So that one should be checked. The equations would have different slopes. Well, that doesn't make sense, so leave that one blank. The next one says the equations would have the same y-intercept. Well, are they hitting the y-axis at the same point? Yeah, because they're the exact same line. That's what makes sense. That one should be checked. The equations would have different y-intercepts. Well, we just said that they had the same, so no, that doesn't work. The graph would look like parallel lines. I don't see parallel lines. I see 2 lines on top of each other. The next one says the graph would look like one line on top of the other line. Okay, that's what makes sense. Okay, they're not parallel because that means they would never intersect. And here they're intersecting at every single point. So these are the ones that should be selected. You need to make sure that you are explaining why that makes sense, or showing me this picture of why it makes sense. Okay, let's move on. All right, so for this one, Jason graphed a system of equations and the graph showed 2 parallel lines. Okay, so if it helps, draw it out, guys. So have your x and y, and let's say here is a parallel line, and there's a parallel line. Okay, they're never going to touch. How many solutions would this system have? Okay, well, think about it. This system, are they ever going to intersect? Are those lines ever going to touch? That's what you're asking yourself to see if there is a solution, because that solution is where they intersect. So are parallel lines ever going to intersect? No, they're not. So are they going to have a solution? No. So this one's going to be no solution. And then you need to make sure that you explain as well, okay? And I kind of give you a hint on how to explain that. Are they ever going to intersect? It doesn't have to be a really long explanation. Just make sure that you explain it. Next one. All right, so now we're actually getting into solving. And this says solve the system of equations by graphing. Be sure to check your solution. Okay, well, they're already both in this y equals mx plus b format. So I don't really have to modify it. I can just go ahead and graph. Remember, when I graph, I start with my y-intercept. So for the first equation, I'm starting with that plus 1. So I'm going up 1 from my origin. And then I'm using the slope, which in this case is -3. And I'm going to put that over 1 because I need that rise over run. And I guess I'll keep that color. And I'm going to start from this point, and I'm going down 3 because it's negative, so down 3. And then this is really like a positive one, so I'm going to the right one. So down 3 to the right one. Down 3 to the right one. And then I can start from here again and go the exact opposite. So I can go up 3 to the left one. See how it continues that line. So I'm going to do it multiple times. Connect my dots as best I can. Put arrows at the end. And I'm going to graph my next line. So I'm going to switch colors so it's a little less confusing. Start with my y-intercept. In this case, it's -7. So I'm starting at 1, 2, 3, 4, 5, 6, 7 down from the origin. So from that point, my slope here, if I don't see a number, I know it's 1, but I can put that over 1. And they're both positive. So I'm going up 1 to the right one from that point. So up 1 to the right one here, up 1 to the right one. Ooh, I can see where it intersects already. Up 1 to the right one. Okay, so I'm going to connect those. And they intersected right here. So for the solution that I think it is, because remember I still have to check, it tells me to check, so that was worth some credit too. I have on my x value here for my solution, it's going to be to the right 2, and that's going to be positive. And then for my y, it went down 1, 2, 3, 4, 5, so that's going to be a -5. So I think that my solution is 2, -5. If I didn't graph it correctly, I know that it's going to be wrong, so I need to check that. So to check, I'm going back to my original equation, and I'm using the 2 and the -5 that I have here. Okay, so I know that this is x and know that this is y. So I'm going back to both of my original equations. So the first equation starts with y. Well, y, I think, is -5, so I'm going to substitute that in. Checking is the same whether you're doing graphing or substitution method, okay? Checking is exactly the same. And then I have -3 times x, which I got as 2, and then plus 1. Now I need to see if this actually is true. So is -6 plus 1 going to be equal to -5? Yeah, that's going to work out. So the first one's good. Now I got to go to the second one. So my second equation starts with y. Excuse me. So y I thought was -5, and then equals 1x, or just x. So x I got as 2 minus 7. Well, is that true? Is 2 minus 7 -5? Yeah, so I know that this is my correct solution. Okay, so there's a lot of work even with just the graphing. So if you have to correct this one, you can use the graph on Jamboard, just use a different color, okay? All right, just make sure you're not erasing your original work, just like you would on a normal correction paper version. All right, next one. So in this case, one of my equations is in that y equals mx plus b, but the second one isn't. So I had to change that one in order to graph it. So I need to get it to be like a y equals, so y is by itself. And it's not like that yet. So in order to do that, I have this minus x. So I am going to go ahead and use the inverse to get it on the other side. So y is by itself. So in order to do that, I need to add x. That leaves me with y equals, and I'm going to put that x value first because remember it's y equals mx, that x value comes first before the y-intercept. So x is just a positive x, and then I have that -3 still. Okay, so now instead of using this, I'm using this equation. All right, I'm going to go back to the first one and go ahead and graph that. So my y-intercept here is -1. We'll start at -1 on my y-axis. And my slope is 3/2. So they're both positive. So rise over run. So I'm going up 3 to the right 2. Do it again. Up 3 to the right 2. Up 3 to the right 2. And I need to go to the left side. So I'm starting at my y-intercept again. And I'm doing the exact opposite. So I'm going down 3 to the left 2. Down 3 to the left 2. All right, connect those. Draw my arrows. Next line. All right, next line is the one that I had to solve a little bit for. So my y-intercept here is -3. Start there. And my slope here is just a 1, right? So I can put 1 over 1. They're both positive. So I'm going up 1 to the right 1. Up 1 to the right 1. And I can keep doing that. I'm going to go back to the left-hand side. I'm doing the exact opposite. So I'm going down 1 to the left 1. All right, down 1 to the left 1. Okay, so it's only hitting right here, okay, because that was where that point was on that green line. So I know where it's hitting. I could keep going down 1 to the left 1, but I have to be really careful with this. I have to know exactly where they intersect. So it's this point here. Now, when I go to see what x and y value that is, it looks like it's going to the left 1, 2, 3, 4 spaces. So that would be a -4 on my x. And it's going down 1, 2, 3, 4, 5, 6, 7. So that would be -7. So I think it's -4, -7. But now I need to do that checking. Okay, and I'm going back to my original problem. So I can't use this one that I solved for. I need to go back to my original. So I'm going to give myself some space. Okay. So looking at my original, in order to check, I'm just substituting in x and y. And for my first equation, it starts with y. So my y value, I think, is -7 equals 3 over 2 times x, which in this case, I think is -4. And I'm going to put that over 1 because I'm dealing with a fraction. And then I have that -1. Okay, so now at this point, I am just going to multiply. So 3 times -4 gives me -12. 2 times 1 gives me 2. Well, that gives me a -6. So -6 minus 1. Does that give me -7? Yeah, it does. That one's good. Okay, so for the next one, this one can be a little tricky, but here's how this works. So this one starts with -x. Well, -x, so I have negative, and then my x is also a -4. So it's like I have a double negative. So I can't just get rid of one of the negatives. I have to keep both of those. And then it says plus y, which y I think is -7. I'm just going to put it in parentheses because there's a plus and a minus there. And then equals -3. Okay, so if I have a double negative here, that's really like a positive. Okay, a double negative will make a positive. So that's like 4. Adding a negative is like just subtracting. So 4 minus 7. Is that going to give me -3? Yeah, it will. So I know that this is the correct solution. Okay, so I can see how that one could be a little challenging. All right, last two. Here we go. If I can get things to work. Okay. This one says you are solving by substitution and then checking. So I'm going to do my best to get all of my work on this screen. So I'm going to kind of use the whole screen if I can. So remember, first step, if you used your notes, which you were allowed to do, totally fine, is to get an equation to say y equals. Well, I already have that, right? This one already says y equals y is by itself. So all I have to do is, if I put this in parentheses, I'm substituting that in for y to solve. So if I do that, I have x plus 2 times y, which in this case is that -1/4 x equals 4. Now, if I go to multiply, I can put this 2 over 1 here, and that's going to give me a -2 over 4 x, and I still have this plus x, so I'm just bringing down everything else. And this I know is like a 1x over here, so I'm going to put that 1 there. And I know that -2/4 is really just -1/2, so I'm going to simplify that right away and just get that taken care of. So that's really like -1/2. So just simplified there. So I have 1 plus a -1/2 x. Okay, so if I have 1, they're both x's, so they're like terms, so I'm going to combine them. But 1 minus 1/2 is going to just give me 1/2. And that's still an x, and I still have equals 4. Well, now at this point, I'm dividing by 1/2, right? Because this is multiplying right here, so I have to use the inverse, so I divide by 1/2. Well, if I do 4 divided by 1/2, that's really like multiplying the reciprocal, okay? So that's like taking 4/1 times 2/1. That's just how you divide fractions. So this is really going to give me 8/1 or just 8. So x is going to be equal to 8. Okay, so far I think x is 8. Now I have to figure out what y is. So in order to figure that out, I go back to one of my originals. It doesn't matter which one you choose, which one looks the easiest to solve. I'm going to go with the first one because y is already by itself, so it doesn't look like as much solving. But you could have chosen the second equation to solve, and that would have been totally fine too. So once I get that x value, I'm using it right away, okay, to find out what y is. So y, don't know what that is yet, so it stays a variable, equals -1/4 times x. Well, I think x is 8, so I'm using 8 here. And I'm going to put that over 1 to deal with the fraction. So that gives me -8/4, which simplifies to -2. So right now I think y is -2. But remember, it needs to be in this ordered pair situation. But I'm going to check it before I put my final solution in. So remember, if I check, I'm just going back to my originals. And I'm showing that in my first one, I think y is -2. So I'm going to substitute in -2 and then equals -1/4 times x. And I think x is 8. So I'm going to put that over 1. Now I need to make sure that this is true. So -2. When I multiply, that gives me -8/4. Is that true? Is -8 divided by 4 -2? Yeah, it is. So this one is good. First equation is A-okay. Second equation. So this one starts with x. X, I think, is 8. So I have 8 plus 2y. So 2 times y, which I think is -2, should equal 4. Let's see if that's true. So I'm going to multiply this first. So that's going to give me -4. I have 8 plus a -4. If I think about Dojo, if I'm at a +8 and I get a -4, is that going to be a +4? Yeah. So I know for a fact that my solution, remember this is x, this is y, is 8, -2. And last question. All right, so number 7 is also solving by substitution, and it also says check your work. So again, first step is to see if there's a y equals, which there is. So you already have that. Now I can substitute. So second step is to substitute that in for the y in the other equation. So I'm going to have -8x plus 2 times y, which in this case, remember, is this whole quantity, and then equals 4 to finish that off. Now I can solve, okay? So I need to go back to like my solving steps for just a normal equation. So distributive property comes first, and I have -8x that I'm just bringing down. But when I distribute, I have a +2 times a +4x, which gives me a +8x. And then I have a +2 times a +2, which gives me a 4. And then bring down the equals 4. Well, now I'm combining like terms. Well, the only like terms I have is -8 and 8. Ooh, okay. So if I have -8x and I add 8x, they're just going to give me 0, right? There's nothing there. They cancel out. So that leaves me with 4 equals 4. What kind of situation is a 4 equals 4? Yeah, it's going to be infinitely many. So in this case, infinitely many solutions is your correct answer. So you wouldn't really have an ordered pair. So hopefully that didn't throw you off too much. Okay, so for this one, to check, there's really not a good way to check it unless you just go back and double check that you distributed correctly, that you substituted correctly. Okay, that's kind of the point of this one, is just making sure that you did all of the correct steps up until this 4 equals 4. All right, so get those corrections turned in. I don't think there's another one, right? Nope, that was just blank. Okay, so get those corrections turned in. I literally just did all of them with you. So get those turned in. And that is really the last thing before you're on break for math. So I am excited to see you guys back on January 4th. Have a good rest of your day.